Hello children, welcome to AIMS India's online classes. In today's video from mathematics subject, quadrilaterals topic we are going to continue. Our today's concept children regarding properties of rectangle, square, rhombus. Rectangle, square and rhombus. So first, let's see the properties of a rectangle. So rectangle is also one kind of parallelogram. It has all the properties of parallelogram. It has all the properties of parallelogram. In addition to that, it has two more properties. They are all angles of rectangle are right angles and the diagonals of the rectangle are equal. So all the angles of rectangle are right angle. In parallelogram, it's not compulsory that all angles are right angles. But in a parallelogram, if all angles are right angles and the diagonals are equal, then it is called as a rectangle. So in parallelogram, all the angles, angle A, angle B, angle C, they may be not equal to 90 degrees. But in rectangle, all the angles should be equal to right angles. That is one property. And the diagonals means line joining the opposite vertices. Line joining the opposite vertices are equal. These two additional properties rectangle is having compared to a parallelogram. So let's draw different rectangles with the different measurements like that. Like this. Let's draw different rectangles. Now draw their diagonals. So AC, BD, so EG, HF, LN, PM. We have to draw the diagonals. So how to draw a rectangle? First we have to take 4 points. 4 points. With the help of 4 points, 4 sides we have to draw such that each angle equal to 90 degrees. So then it will be a rectangle. In the rectangle, now we have drawn the diagonals. If you measure the diagonals, here in rectangle ABCD, diagonal AC, joining A and C, opposite vertices, joining B and D, opposite vertices. Let's measure the diagonals, both the diagonals with the help of scale. So let's measure diagonals here also, HF and EZ. Let's measure diagonals here also, PM and LN. If you measure the diagonals, so we will find that this AC equal to BD, EZ equal to FH, LN equal to MP. So we can conclude that the diagonals of a rectangle are equal. The diagonals of a rectangle are equal. That can be concluded. So this property that diagonals of a rectangle are equal can also be proved in another way. Suppose PQRS is a rectangle with the diagonals PR and QS. To prove, we have to prove diagonals are equal. PR equal to QS. Now, let's consider the triangles. PQS. This is one triangle. PQS is one triangle. Triangle PQS. And PQR. This is one triangle. Second triangle. So we have two triangles. In this, PS equal to QR. So why? PS and QR are opposite sides of rectangle. They are equal. So opposite sides of rectangle. And SPQ equals to RQP. Both are right angles. Because in right angles, each angle equal to 90 degrees. And in PQS and in PQR, we have PQ common side, PQ or QP. PQ equal to QP, common side. So here one side is equal, one angle is equal, another side is equal. So through SAS property, side angle side property, we can conclude PQS is congruent to PQR. These two triangles are congruent. These two triangles are congruent based on SAS property. Based on SAS property. So, if two triangles are congruent, their corresponding parts also will be equal. Here, SQ is one side in this PQS triangle, PR is one side in this PQR triangle. So, this SQ equal to PR. So, QS equal to PR. So, this QS equal to PR. QS equal to PR. So, QS equal to PR. So, Y means corresponding parts of congruent triangles. In shortcut, we can write it as CPCT. According to this CPCT property, QS equal to PR. So, diagonals are equal. This is proved. Diagonals are equal, that is proved. Next step. So, diagonal properties of a rhombus. Diagonal properties of a rhombus. So, already we have learned rhombus is a kind of parallelogram with equal sides. With equal sides. So, the properties of parallelogram holds good for rhombus also. So, for parallelogram, whatever properties it obey, rhombus also it obey same properties as it is a parallelogram. Along with that, so it have additional properties. Opposite angles of a rhombus are equal. It is there in a parallelogram. Diagonals of rhombus bisect each other. So this is additional property. Diagonals of rhombus bisect each other. So here, so rhombus is a kind of parallelogram in which all sides are equal. Along with that, diagonals will bisect each other. Diagonals will bisect each other. This additional property is there that we have to prove. So let us draw three different rhombuses and draw their diagonals. Let the diagonals intersect at O. Measure the adjacent angles formed at point O. So let's draw. With equal sides, let's draw different rhombuses like this first figure, second figure, third figure. Let's draw different rhombuses and let's try to measure this angle AOB. This angle AOD. This angle AO means both angles AOD, AOB and AOD. Two angles. AOB, AOD. Two angles. AOB, AOD. Two angles. So how are these two angles? These two angles are adjacent angles. Adjacent angles. So in each diagram, we have to measure AOB and we have to measure AOD and we have to check whether they are equal to 90 degrees or not. 90 degrees or not. So after measurement, we can conclude that each angle equal to 90 degrees. So this angle 90 degrees. So this angle 90 degrees. This angle 90 degrees. Adjacent angles are 90 degrees in rhombus. That we will observe. That we will observe. In the same way, these two also, COD, COD, COB, these two also are adjacent angles. If you measure them, they will be also equal to 90 degrees. So, these two diagonals intersecting perpendicularly. Intersecting perpendicularly. If they intersecting perpendicularly. So, okay, intersecting perpendicularly. If you take any two triangles, suppose if you take this triangle and this triangle, if you compare these two triangles, if you compare this angle, this triangle and this triangle, compare these two triangles. So this OD is the common side, OD is common side, AD equals to CB, they are equal because in rhombus all sides are equal. This angle 90 degrees, this angle 90 degrees. So according to SAS property, this first triangle, this second triangle are congruent. So corresponding angles are equal. Sorry, corresponding parts are equal. So OA equal to OC. So diagonals are bisected. And we have 90 degrees here. So diagonals are bisecting each other at right angles. Diagonals are bisecting each other right angles. That can be proved. Let's see this. So rhombus ABCD is there. AC is the diagonal. BD is the diagonal intersecting at O. To prove OA equal to OC, OB equal to OD, means they bisect each other, and AOB 90 degrees, COB 90 degrees, means we have to prove they bisect at right angles. That we have to prove. For that, let's take triangles OAB, AOB, COB, this triangle, first triangle, this is the second triangle. Let's take these two triangles. So in this, triangle, OAB equal to OCD. OAB equal to OCD, this angle. I'm sorry, student, here it is somewhat wrong. So instead of this point, we can take this point. Okay, correct only, children. But they have taken triangles OAB. These two triangles, triangle 1, OAB, ODC. These two triangles they have taken. These two triangles they have taken. In this angle equal to this angle. Y means AD is parallel to CB. This is the transversal. So these two will be alternate angles. Transversal upside, transversal downside. Alternate angles. So angle OAB equal to OCD. This we have got. In the same way, this OBA equals to ODC. This angle also will become equal. So Y means these two lines are parallel. This is the transversal upside, transversal downside, alternate angles. These two are equal. And AB equal to CD because opposite sides of rhombus. In rhombus, all sides are equal. So two angles, one side. So according to ASA property, two triangles are congruent. Two triangles are congruent. So this is the congruent symbol, children. Two lines above similar to symbol. Two lines with similar to symbol is called congruent. So if they are congruent, remaining parts also equal. CPCT means already we have told. Corresponding parts of congruent triangles. So in these two triangles, OA equal to OC and OB equal to OD. OB equal to OD. So diagonals are equal. Diagonals are equal. That is proved. That is proved. So next. In triangle OAB and OBC, in these two triangles. So OA equal to OC proved. OB common. And AB equal to BC because sides of rhombus. So three sides are according to side property. According to Tribulas property, they are congruent. So if they are congruent, corresponding parts to be equal. So this angle equal to this angle. So AOB equals to COB. This is X, this will be X. But these two will form a linear pair. X plus X, how much? 2X. 2X equal to 180 degrees. So X equal to 90 degrees. What is X? This part is X, 90 degrees. This part is X, 90 degrees. So they bisect each other at right angles. So that is proved. Next. So next, to prove that diagonals of a rhombus bisect the interior angles. So we have one more property. So here, if you see here, so this AC is the diagonal of rhombus. It bisects angle A into two parts which are equal. A equal to small b. And BD is the diagonal of rhombus. It bisects angle D. Means angle X equal to angle Y. So means this BAD angle, CDA angle are interior angles. The diagonals will bisect interior angles that we have to prove. So in triangle AOB and AOD, these two triangles, OB equal to OD. Why? Diagonals bisect each other, already proved. OB equal to OD, diagonals of rhombus bisect each other. And AOB, 90 degrees, AOD, 90 degrees. They bisect each other at 90 degrees. Already proved. And AO is common side. So SAS property, they are congruent. So if these two triangles, this is one triangle, this second triangle, if they are congruent, these two triangles are congruent, corresponding parts also equal. So angle A equal to angle B. In the same way, if we take these two triangles, we can prove angle X equal to angle Y. So this proved diagonals will bisect interior angles. So a rhombus has all the properties of parallelogram. Addition to that, we have which properties? All sides are equal. Diagonals bisect interior angles. diagonals bisect each other, diagonals cut at right angles. If along with parallelogram, if all these properties are satisfied, then it will be called as a rhombus. So in rhombus ABCD we have all sides are equal, interior angles are bisected, diagonals are equal, diagonals are bisected at right angles. But diagonals of rhombus are not equal. Suppose if this is in this rhombus, AC is not equal to BD. Diagonals are not equal. Only OA equal to OC, OB equal to OD. Only in the same diagonal, these two parts are equal. But two diagonals are not equal. That to be remembered. Next one. Properties of a square. Properties of a square. So square is also a kind of rectangle. It has all the properties of rectangle. Along with that, its diagonals are equal. Its diagonals are equal. And sides are equal. Sides are equal. So square is also rhombus. In rhombus, all sides are equal. So it has all the properties of rhombus. So sides of square also equal. So diagonals bisect each other at right angles. Diagonals bisect interior angles. So here square is having the properties of both rectangle and rhombus. Like rhombus, sides are equal, diagonals bisect each other at right angles, diagonals bisect interior angles. Along with that, like rectangle, diagonals are equal. In rhombus, diagonals are not equal. But in rhombus, if diagonals are equal, then it will be a square. So sides of square are equal, diagonals of square are equal, diagonals bisect each other at right angles, and this here, because this diagonal bisect this right angle, this part will be 45 degrees, above part will be 45 degrees, this total part will be 90, these two parts will be 45 degrees. So the diagonal makes an angle with the side 45 degrees, makes an angle 45 degrees with the side. Next here, we have properties of kite. So, what are the properties of kite, children? Diagonals are perpendicular to each other. So, AC perpendicular to BD. This diagonal bisects this angle B, this angle D. So bisects the interior angles. Next, opposite angles are equal. Angle A equal to angle C. OA equal to OC. Diagonals are bisected. OA equal to OC. And diagonal BD divides the kite into two congruent triangles. So one is ABD, other one is BCD. Two congruent triangles. So kite will be having all these properties. So this, along with that, in kite definition already we have learnt. Adjacent sides are equal. So AD equal to CD, AB equal to BC. So in triangle ABD, CBD, ABD, CBD, two triangles. So AB equal to BC. It is given in the property of kite. Adjacent sides are equal. AD equal to CD. AD equal to CD. Adjacent sides are equal. And BD equal to BD. Common side. Common side. So SSS property, they are congruent. If they are congruent, corresponding parts also equal. So A, B, D, this part equal to this part equal to this part equal to C, B, D, this part. So if this part equal to this part, we can tell that diagonal will is bisecting angle B. Angle B. A, D, B. This part equal to C, D, B. Corresponding parts are equal. So the diagonal bisects both D and B. The diagonal BD bisect both B and D. It is proved. It is proved. So next. A, B, C, D. BD is the diagonal. AC is the diagonal. O. Adjacent sides are equal. If you compare the triangles AOD and COD, these two small triangles, so AD equal to DC given in the definition of kite. So ADO, ADO, CDO. This angle, same, just now we have proved. And OD, common side. So side angle side property, these two smaller triangles also congruent to each other. So remaining parts are equal. AOD equals to COD. So this angle equals to this angle, but these two angles will form a linear pair. So each one will be equal to 90 degrees. Each one will be equal to 90 degrees. So bisect perpendicularly. That we can tell. Like this, children, we can prove all the remaining properties. These are the properties of a kite. Next, children, properties of an isosceles trapezium. Properties of an isosceles trapezium. Trapezium means one pair of parallel sides. One pair of parallel sides. That quadrilateral will be called as a trapezium. If non-parallel sides are equal, then it is called as isosceles trapezium. Because this AD and CB, BC are non-parallel sides, they are equal. So it is called as an isosceles trapezium. So AB is parallel to CD and AD equal to BC. So it has the following properties, children. So A plus D. So adjacent angles are supplementary. B plus C. This also. Adjacent angles are supplementary. Means co-interior angles. Co-interior angles. This X and U are called. These two are the parallel lines. This is the transversal. So these two are called co-interior angles. In the same way, these two are called co-interior angles. So sum of co-interior angles equal to 180 degrees. So they are supplementary and. So angle A equal to angle B, and these two angles are equal. Angle C equal to angle D. These two angles are equal. The diagonals AC and BD also equal. So these are the properties of isosceles trapezium. Okay, children. Some example problems are there. We can learn later. Next video, we will discuss in next video, children. So thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.